Good evening, all. Welcome to DSA with Python training, day 4. Hope everyone is doing well. So, if my audio is clear, just reply me in the chat. Hope audio is clear. Okay then. So today what we do is we'll source some more questions on a list data structure. Okay, so more programs will work out using the list data structures. So in previous video, we solved some of the programs using list data structure. So if you have not attended that session, so please go back to my channel and watch the day 3 video containing programs on list data structure. Then come back to this video. So this is not about Infosys training. Okay, so we'll take up. If you have any queries, you type your queries in the Infosys WhatsApp group. Okay, I will reply to you, but not here. Okay, so related DSA, if you have any doubts, you can post your doubts in the chat. We'll discuss them. Right. So let us start the session. Let us go with today's first question. So it is given, create a new list containing only the numbers from a given list. So you have a list. Okay, so containing both numbers and strings. Hope strings may be present in that. Okay, so you need to need to create a list which contains only numbers. That means those strings you need to eliminate. Got it? Only numbers should present in the new list. So let us take an example list here so that you can understand the question easily. So we'll take a list containing both the combination of numbers and strings. Okay, so assume this is my list. So containing some numbers, say 5, 10, 8. Okay, so some names or some strings, something like hello. Okay, right. So then another number, something like 7. Okay, so then 12, then one more string like world. Okay, so then say 15, then another string like welcome or some fruit names you can include. Okay, so such list combination of numbers and strings present with us. Now you need to eliminate these strings from the list and create a new list which contains only the numbers. Okay, so this is what the question. A new list containing only the numbers from the given list. So this is our given list. This is our given list. Okay, right? So how do we do that generally? That means mathematically you can just say that since this is number, this is number, this is number, this is string, you eliminate this. Okay, so include only numbers from this so that you will get this. Okay, but when you see an element in the list, okay, like some element you have uh, encountered in the list. Okay, so the first element you have read from the list. Then how do we know that whether it is a number or it is a string? If you can figure out this, okay, whether it is a number or whether it is a string. If you can figure out if it is a number, then don't disturb that or include to the new list. Include to the new list. If it is a string, just throw it out or go to the next element. Go to the next element. Okay. So because this is a string, it is not added to the new list. Okay. So, but how do we know that it is a number or it is not a number? Okay. So that we need to identify. Okay. So item by item, we need to read from the given list, and then if it is a number, add it to the new list. Okay. So what we do is first let us print the original list so that you can understand. Okay. So how we can print? By using the formatted string f, and within the single quotes or double quotes says you want the text to be printed here. Okay. So something like original list colon. Okay. So here the list should be printed. Okay. So then here I'll say list one because list is already a predefined function name. Better we use list one here. Okay. So then I say list one. Then double quotes close. The variable name must be placed inside the braces here. Okay. So then close this. This is how we can print the original list. Got it? Okay. Now what we do is for this, that means we want to find out whether it is a number or a not. Okay. So for that in Python, there is a function called as a is instance. There is a function called as a is instance. Okay. So what you can do is for this, you pass the element or item. Okay. So then in the second argument, you can pass the type called as which type you want to test whether this item is an instance of int, float. Okay. So you can give the data types in the second argument place. Okay. Separate them with the commas. More than one means you enclose them in parentheses, separate them with commas. Okay. So that means this checks is instance function. Okay. So gets the item. It checks whether it is an instance of int or float. Okay. If it is an instance of int or float, then it is confirmed that it is a number. It is a number because everything is implemented as object. Even numbers also implemented as objects inside the Python. Okay. So then it checks whether it is a instance of, that means whether it is an integer object or floating point object. True means it is a number. Okay. So then you can add it to the new list. Otherwise you can, if it is a string, it returns false. Okay. So that's how you can traverse the list element by element. Okay. So this list, whatever list given, you traverse the list element by element. Then if it is not a number, just go to the next element. Okay. If it is a string, okay. So don't add it to the list. Just leave it and go to the next number. And if there is a number, go on adding them to the new list. Okay. So for this, what we require a new list. So we define new list here. Okay. So this an empty list will create so that we can go on adding them to the new list. If it is a number, we'll go on adding to the new list. This is our logic here. Okay. So what we need to do, we need to create a new list containing only the numbers. Okay. So that means we need to traverse. When you are traverse, that means you need to use a for loop. So since you can solve this by using a for loop, so better use list comprehension here. Okay. So you can also write using the for loop and use this method. Okay. But better make a habit of directly writing the list comprehension here. Okay. So that means no need of uh, initialize or create the empty new list here. Yes or no? Okay. So directly you can create the new list by list comprehension here. Okay, so how do we create? Directly we can write like this, I think. Okay, now see, new list should contain all the items. New list should contain all the items. Okay, so where from these items should come? They should come from this list one. Okay, so that means you need to traverse this list one. For that, we should use a for loop here. Okay, so for item, I said after for whatever name you use, it should be the same name here. Okay, so for item in list one, for item in a list one. So for item in list one means what this for loop will do, it gets each item, each element from list one and assigns to item here. Okay, so that item must be placed in the new list. Okay, but directly do we need to place? No, we need to place inside the new list. No, no, no. If it is an instance, if it is a it is instance of a integer or float, then only we can add them to the new list. Okay, so that means here you need to use the condition. Okay, so before adding to the list, now we instruct the Python to check. Okay, so if item, okay, so we need to pass this as argument, so what we do is we use if is instance of function we'll use here. Okay, so if is instance of, if is instance, okay, so here we'll pass the item, and second argument will pass int comma float. Okay, so that means whether it is an integer or floating point number, then it becomes a number there. Yes or no? Right. So so if if is instance item integer or float, if it is an integer or floating point instance this item, then you add to the new list. That is what we are informing the Python compiler. Okay, so then close this. That's it. This is a one line code. Okay, so three things we included: one condition, one for loop, and adding a item to the new list. Adding item to the new list. Yes or no? Okay, so is instance. This is parenthesis. You must take care of parenthesis. See here. This is closed here. So is instance method you need to close now. One more parenthesis required here. Okay, so now you got the new list here directly. Now if you print it should print a new list with only numbers. Okay, so then you can say that new list containing only numbers. Some text you can print here containing only numbers. So where from? This is from new list. So variable name must include in a braces. Okay, so then close. If it is single quotes, close single quotes. Double quotes, close the double quotes. Okay, so better use double quotes so that easily you can locate these double quotes. Okay, so then close the print function. That's it. You will get the new list. Okay, so let us see the example. Let us straight away go to the online Python compiler, and straight away we'll execute this and we'll check. So what we do is we define list with some numbers. I am just whatever. Yeah, so this is our uh, online compiler. Okay, so some random numbers, some names I have included there. Let us run this code and verify whether our code works or not. Okay, so is instance method we are using, function we are using here, item comma int comma float, it is testing with the int or float. Okay, so let us run the code. Now you can see original mixed list. Okay, so this is original mixed list containing only numbers 1, 2, 3, 4, 5, 6. Now all strings are eliminated from the removed from the list. Got it? So this is how you should develop some logic. Okay, so practice these kind of questions to improve your problem solving skills. Now, always I said that uh, this is pretty simple if you use is instance function. Okay, so but the question is without using is instance function, assume that this is not available is instance function. Okay, so then how do we find out the logic? That is very important. Okay, so there you can actually learn the logic building. Okay, so always think of on those lines, right? So shall we write code for that? That's how you should start implementing the actual logic inside this is instance function. Whatever logic is implemented, okay, so that you should able to write on your own how this is instance method has been implemented, how it is figuring out whether it is integer or a string. Okay, so that kind of logic you should develop. Okay, now let us implement the same thing. Okay, so we'll write code for that. What we do is right. So here instead of using is instance function, now you define your own function. Okay, so that also you should learn defining your own function. These kind of tasks, if you can uh, figure out a function which does the task. Okay, so for example, how our main function will be. Okay, so I'm just writing the main function. So this is my main function. Okay, so somewhere here I write main code. Okay, so here what we require some list one containing some numbers. Okay, so like sorry, it should be number, no? So no problem if it is a string, no issue. Okay, so something like 1, 2, 3. Okay, so some examples like in example I am taking a different string. Okay, so don't get confused. 4, 5, 6 world. Okay, so something like this 6. something like 7, 8 you can include. So then what we need to do? We need to define our own function like a filter numbers or something. Only numbers you should filter, okay? And pass this list one as a argument. So list one I am passing as a argument, okay? So this returns a new list, okay? So that new list will store in a variable called as a new list, okay? So then we can print the original list and new list, okay? So that code you can write here. If you print original list and new list, it prints the new list, okay? But here we are calling the function called as filter numbers and passing our list, okay? So this function you should able to define here. So to define a function in Python, we use the keyword called as a def, okay? Then followed by function name filter numbers, okay? So then what it is getting? List one we are getting, okay? So then I say just L here, okay? So L is my original list here. L is my original list. Yes or no? So here what we required? We required a new list. So we'll create a new list, empty list here. A new empty list we create because we need to add numbers to this new list. Okay. Then we'll traverse the old list element by element. So for this we require a for loop here. Okay. So for item in L. Okay. So this is our L. This is our L. So for item in L, first it gets the first element 1 inside the item. Okay. So here what you need to do is you need to find out if it is a number, then if it is a number, then you need to add it to the new list. Otherwise, leave it. Okay. So for that, what you can do is you can just use the functions like type conversion functions we have. Okay. So int, float, type conversion functions are there. Okay. For example, I give you an example here. Okay. For example, if you pass a string something like 1988. Okay. And if you give this string 1988 to int, so it prints the output 1988. Okay. So it converts the string into integer and returns that one. Okay. So 1988 is returned. Similarly, float. If you pass it to float, okay. So then 1988. Okay, so then it returns a 1988.0 like this. These type conversion functions you can use here. Okay, so if you pass an integer number to a float, say for example float 5, what it returns? It returns 5.0. It returns 5.0. It returns. Okay, so here what we do? We use these type conversion function. Okay, so for float function is used, you can use for both int and floating point type checking here. Okay, so then what I am doing is I am just converting the item into, okay, I am converting the item into floating pointer type. Okay, so then say float item, convert the item into float. That is what I am saying here. Okay, but here the problem is if you use like this for this intent, okay, so if the string contains only digits, then it can do. But if you ask the int function like this hello and ask it to convert into integer, then it raises an error. Okay, it raises an error. Even the float function also raises an error. But in our case 1 2 3 after you will get hello. Okay, so then float hello, if you ask float function to convert hello into floating point type, then it raises error. Okay, so that means whenever an error is raised, it indicates that it is a string. It indicates that it is a string of characters. It is a string of characters, not a digit. String of not digits, string of characters, which an int function or float function cannot convert into int or float. Okay, so that means the conversion fails there. Okay, so in such case it raises an exception, no? Okay, so whenever an exception is raised, to handle that, what we can do is, okay, so we can use those exceptions, keep those exceptions inside the try block. Okay, so like try catch blocks in Java. Okay, so here we have try and except. Okay, because this statement may raise an exception. Okay, this statement may raise an error. Okay, so that's why I am including this inside the try block. Okay, so try colon then followed by float item. Okay, so if it is a number, then it won't raise any exception. Okay, so otherwise what happens, it raises an exception. Okay, so when it raises an exception, okay, what I need to do, I need to handle that exception. Okay, so if a exception is not there, now what happens, inside the try item will be converted into floating point type. If it is converted successfully, okay, then I need to add that item to the new list. Okay, so then I say, if it is success, then I say new list dot append. Okay, so new list dot append, then I say item. New list dot append item, it will be added. Okay, so if it raises, then this statement is not executed. Here you will get the error. Okay, it won't come to this statement, it won't come to this statement. From here it jumps to except, it jumps to except block. Okay, so instead of catch, in Python we call it as a except. Okay, we call that as a except block. Okay, so you can see the full screen here, right? Now inside the except, what we need to do, we need to handle the exception. Okay, so here except, what kind of errors you want to handle, you want to handle value error. Okay, so for some type error, you can write all the kind of errors you want to handle here. Okay, so the best things is use value error and type error here. Okay, so then followed by colon, then followed by colon here. Okay, now so when the controller from inside the try block comes to except block. Okay, so that means when this float function fails, okay, so from here directly the control jumps to this except block. Okay, so when it has reached to the except block, meaning that it has encountered a string from the list. Okay, so then what we need to do, we don't want to handle this, simply we want to continue to the next element. We want to continue to the next element. Generally, if you don't write here, your program stops. If you don't handle this exception, your program stops abnormally here itself. It won't go to next elements in the list. Okay, so but we want to move the control or process our program going to the next element. Okay, so for that we write some code here. Okay, so what is our code, because we don't want to use that string inside the new list. Okay, so just we'll write the code called as a continue. That means whenever an exception is raised, just we informing Python to continue. So what happens, again from here the control goes to the for loop. Okay, so then item gets a next element, item gets a next element. Okay, so say for example item gets 2. Okay, so 2, then inside the try it checks float 2, successfully it converts 2 into floating point type. Okay, so then new list dot append item. Okay, so 1 2 will be added. Okay, so then when there is no exception raised, this except block is not executed. This you should understand. Okay, you should understand this. Then what happens, from here the control goes back to the list, then item, next item, it gets 3, it gets. Okay, inside the try float of 3 successful, new list dot append, your new list contains 3. Okay, so then from here it goes back, next it gets hello here. Now item gets hello. Now what happens, we'll see inside the try float hello, float hello, that's meant. Okay, so here and error is raised, exception is raised, from here the control comes to except block here. Okay, so then what we are informing, it raises a type error here, then continue we are saying. So from here the control again comes back to the for loop. So it gets the next element, that is item gets the next 4. Okay, so 4 will be added, then 5 will be added, next world it gets, then exception comes to the except block, continue goes. Okay, so then gets the next element 6. Okay, so 6 will be added, 7 will be added. Now your new list contains only numbers, that's it. Okay, so like this you will get the new list. Then when you complete the for loop, okay, after coming out for loop, exactly below the for loop, now you return the new list, you return a new list. Okay, so that new list comes here. Okay, so then that is caught inside the new list in this main code, and when you print two print statements, original and new list, it will be printed. Okay, so this kind of logic also you should able to figure out. These things you should learn, because in interview sometimes if you write a code using the first logic, okay, so this logic if you use, and immediately the interviewer may ask, okay, so can you write the same program without using this predefined function, then you should go for such logics. So these logics you can develop only by practice. Okay, so if you practice number of problems, and then you will able to find out the solution for the given question. Oh, this I can handle by using try and except block. Then easily you can write a code in the interview. Let us execute this code and let us verify. Okay, so we'll go to our online compiler. Okay, so then let me copy the code onto the compiler. Done. Okay, so let me display the online compiler to you. Yeah, this is there. Got it? Right. Now you can see the code. Now you can see the code. Okay, so this is my list one, and this is new list. I'm calling the function filter numbers with the list one here. Okay, so then I'm printing the original and numbers only list here. Then inside the function, again, some input list we are passing here. Okay, so then now you can see converting into float and adding the item to the list if there is no error. Otherwise, it comes to this except block and continues. That's it. So let me run the code. Now you can see original list and a new list containing 1, 2, 3, 1, 2.5, 3, and 4 here. Okay. So why this 4 included? Because 4 is a string containing the numbers. 4 is a string containing the numbers. Okay. So that's why that 4 it is successful. Okay. So it is able to include this. Okay. So now the question is numbers only numbers kind of things it is including in this. Okay. Like alphabets kind of strings it is able to remove. Yes or no? So if you want to figure out this also, okay, so still uh, you need to add some more code so that only numbers kind of things you can add to the list. Okay, so try out this. This is an exercise problem for you. Okay, so if you figure out this and if you come up with only these numbers, okay, so share your code. Okay, so your assignment in the comment box of this video. Let me see how many of you will complete this assignment. Got it. Done. So let us move with the next problem. Now create a list of first n prime numbers. The next problem is create a list of next prime numbers. Next first n prime numbers. List of first n prime numbers. Okay. So say for example first 5 prime numbers. N value if you take 5. Okay, so the first 5 prime numbers you should generate. What are the first 5 prime numbers? 2, 3, 5. Okay, so then 7 and 11. Okay. So n value indicates the first 5 prime numbers, not prime numbers up to 5. There is a difference. Okay, prime numbers up to 5 when you say it generates only 2 comma 3. Okay, but first n prime numbers when are asked, okay, so then you should generate 5 prime numbers starting from the beginning. You should generate 5 prime numbers. Okay, so these are the first 5 prime numbers in our natural numbers. Got it? So how do we do this? How do we do this? That means given a number, that means each number you will get to from the natural numbers. Okay, so then you need to test whether each number is a prime or not. If it is a prime, then add to the list until the list contains prime numbers equal to given n value. Okay, so like this, you should go on adding the prime numbers if it is a prime. But how do we know that whether a given number is prime or not? That is the question. Okay, 5 is given. Whether this 5 is a prime number or not, how do we test? Okay, so mathematically, we know that if the number is divisible with 1 and itself, okay, so then we call it as a prime number. We call it as a prime number. So one logic, what you can do is simply you can start with 1, okay, and start your count value as a 0 here. Okay, so from 1 to that number, that means you go on dividing this 5 with 1 to that number. Okay, so start dividing with 1 first. 5 divisible. Then go on count how many times it is divisible. Count value becomes 1. 5 divisible with 2? No. 5 divisible with 3? No. 5 divisible with 4? No. 5 divisible with 5? Yes. Then increment count value. Okay. So count value becomes a 2 here. So finally, if your count value is 2, then you decide it is a prime number. This is one logic. Okay. But instead of traversing the loop, if your number is very big number, like 10-digit number, okay, so it takes a lot of time for your loop to decide whether that number is prime or not. Instead of that, what you can do is the best way of checking whether a number is prime or not. Okay, so is for example, let us look at a number called as a something like a 17. We'll see. Okay, so what are all the numbers for the 17? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay. So it is divisible with these two numbers. Okay. So what you can do is you can find out a square root of this 17. Okay. So square root of this 17 means approximately it is a 4. 4 4 is a 16. Okay. So square root of 17 means approximately it is a 4. Okay, so that means if you can start checking starting from second number onwards, okay, 2 to 4, if you go on test this, if you go on test this, okay, if it is divisible with any one of these numbers, if it is divisible with any one of these numbers, okay, then it is not called a prime number. It is not called a prime number because after the square root, whatever numbers you encounter, these no need to check again for these numbers. Okay, these are simply the multiples of these numbers only. Okay, the remaining numbers after the square root are multiples of these numbers only. You can just see here. Okay, so 6 multiple of 2 only. Okay, so 7 anyhow odd number. Okay, so prime number that is also. Then 3, 6, okay, 8 multiple of 2, 9 multiple, all these uh, multiples of these numbers only up to square root, whatever numbers are present, their multiples only this present. Okay, if it is divisible with one of these three numbers, then you can also say that it is divisible with these numbers, one of these numbers. Okay, if it is not divisible with these numbers, definitely it is not divisible with any of these numbers multiples. Got it? Okay, so that's how you can reduce the iteration up to the square root. Okay, so these many numbers you are eliminating here, you can reducing the loop iteration these many times. Okay, so this becomes efficient code here. This becomes efficient code. Okay, so we'll implement this logic here. We'll implement this logic here. Okay, so for this, what we do is we need to define a simple function. We'll define is prime given a number. Okay, so it checks whether a given number is prime or not. Okay, so that logic we will. Got it? Okay, so first we'll define a function called as a is prime. Okay, so how we can define a function like is prime function, we can define is prime. Okay, so something like num we are passing. It checks whether this num is a prime or not. If it is prime, then it returns a true. Otherwise, it returns a false. Okay, so we know that if the number is less than 2, okay, so it is not a prime number. So then what we do is we'll return a false. We'll return a false. So otherwise we go on checking whether after 2 if it is divisible or not. That is what we'll check up to the square root only. Up to square root only we'll check. Okay. So for this we use a for loop here. Okay. So for I in range, for I in range. Okay. So where from 2 to. Okay. So starting from 2 to. Okay. So square root of num. Okay. So square root of num you can write like this, num to the power of 0.5. Num to the power of 0.5 is nothing but, okay, so square root of num. So it returns a double type value. Now you convert that into integer type value. Okay, so but extra plus 1 you add so that the number is also included. Otherwise it stops it before number only. Okay, so that's why plus 1 means it includes up to n value. It includes up to, that means square root value, exact square root value it includes. Okay, so otherwise it stops at before number only. Likely square root of 4 means it stops at 3, but we want to check with 4 also. Yes or no? Okay, so that's why I'm adding plus 1 here. Okay, so then what we'll do, we'll check if it is divisible with any one of these numbers. It is confirmed that it is not a prime number, so directly you can return a false there. Okay, so now I am testing that if your num mod I, okay, so if your num mod I is equal to 0, that means it is divisible. The meaning is it is divisible, so no need to check with other numbers. Directly you can say return a false. You can say return a false. Okay, so with all these numbers, if it is not divisible with 2, 3, 4 up to the square root number, if it is not divisible, then you can confirm that it is a prime number. So after coming after from the loop, directly you can return true here. This is a simple function which tests whether a given number is prime or not. This function is required because each number will pass to this function. It tells us this is prime number, this is not prime number. Okay, so we'll pick out only prime numbers and add it to our list. So our task becomes simple here, becomes easy with the help of this function. Okay, so this is one function we defined here. Then the second function is we need to generate the prime numbers up to n. No, simple case. Okay, so for that also we can define one more function. It is better to complete the logic with the help of functions. So this you should develop in Python. Okay, so generate something like a prime numbers or something primes. Generate prime numbers, primes, some name you can use here. Okay, so up to which, up to n you want to generate, n prime numbers you want to generate. Okay, so here what we do is we define an empty list called as a primes. Okay, then every time we ask is prime function, and if it is says it is a prime number, then we add to this primes list here. Okay, otherwise we don't add to this list until the list contains 5 elements. Then we go on checking one by one, starting from number 2 onwards. Okay, so that's why what we do is we'll take the initial number as a 2. we'll take the initial number as a 2. Okay, so then we go on testing this. Okay, so how we can test? While while length of this primes. Okay, so length of the empty primes list, length of this primes list. Okay, so as long as it is less than n, you go on adding to the list. Okay, so that means it repeats until your primes list contains 5 prime numbers. Okay, so it repeats. Now what we need to do? So initial number we got 2. Okay, so then we'll ask our is prime function, if is prime, if is prime, okay, if is prime num, if num is a prime. Okay, so if num is a prime, what we need to do? We need to add it to this primes list. Okay, so then we'll say this function already we defined here, this function we defined here. Okay, so it returns true if it is a prime number, otherwise it returns false. So if it is a prime number, what we need to do? We need to add it to this list. Okay, so what we'll do? We'll say primes dot append, primes dot append, then we'll say num. So num will be prime number added to the primes list, otherwise no. Go to the while loop again. Okay, so checks here, then we generate the next number. So we got the num value 2, no? Then you can go to next number 3, then you can go to next number 4. Okay, so that means this if condition is false. Okay, so then it comes here. So we'll increment the num value, num plus is equals to 1, this entire thing inside the while loop. Even if this is true, added, and it goes to the next number, goes to the next number. Okay, so like this it repeats with all the numbers until your prime contains 5 prime numbers. Okay, so this you return that new list, you return from this function. So return, then you say primes list, primes, that's it. So this generates the prime numbers and returns that list here. So this is your code. So this becomes easy if you write a code in the form of functions. Okay, so then understanding the logic becomes very easy. Okay, so entire logic if you include inside the main. Okay, so then following the logic sometimes becomes difficult if you are getting error. Okay, so why I'm getting that error, you don't understand. Okay, so sometimes, for example, some non-prime number like 4 is added into your list. Okay, so then you can just check out the function is prime number function, is prime function is there, no? So that means there is some problem inside this function. It is saying that 4 is also prime number, it is saying that 4 is also a prime number. Okay, so only if you debug this function, that's enough. That is the advantage of defining these functions, right? Let us write our main code here. Okay, so what is required inside the main code? Some n value we required. Okay, so we'll generate a first 5 prime numbers. We want first prime numbers. Okay, so what we do? We ask the function called as a generate. Okay, so prime numbers, generate prime numbers function we'll ask. Then we'll pass this n value here. It generates and returns the list, no? Okay, so that list you catch something like in a variable called as a L or prime list. Okay, now you can print this list here. Okay, so if you print, just you say, if you print this list by using this formatted string, the first n prime numbers are something, you can print like this. The first n value should be enclosed in braces. The first n prime numbers are. Okay, so here we want the list to be displayed here. Okay, so then you can just place that L here. So it prints that close this. Even you can use this if you don't want to use f here, just you use this string, then put comma and add l. That's it. Got the logic? Okay, so this is a simple logic to generate a first n prime numbers. So we define two functions. Okay, so this the function definitions. Writing functions we should learn in Python, especially in Python. This is required most. So let us run our code. Okay, so the same code I will type in the online compiler. Okay, so let us go to our online compiler. Let me share this compiler screen. Now this is our code. Is prime function we defined here. Generate primes. This also we defined here. Okay. Then inside the main function, first I am specifying n value here. I want first five prime numbers. Okay. I'm asking this function generate primes to generate n prime numbers. It returns the new list here. Okay. So that we are printing here. Let us run this code. Now you can see the first prime numbers are 2, 3, 5, 7, and 11. Same whatever we discussed we got. So if you change n value, then the list will increase. Okay. So it is not up to 5. It is five numbers. The list should contain n prime numbers. If I say n value as 8, okay. So if I run this code, now you can see 8 prime numbers, the first 8 prime numbers. Okay. So if you change n value as 10, then it lists first 10 prime numbers. It prints, see here, 10, first 10 prime numbers, see up to 29. Okay. So 1, 2, 3, 4 up. Then 10 are there in this list. First 10 prime numbers. Okay. So this is how uh, the program prints n first n prime numbers. There is a difference. Prime numbers up to n. Okay. So first n prime numbers. Okay. So the logic will change. Any doubt in this? So this way you practice more and more programs using list data structure. Okay. So you'll get more hands-on practice with list data structure. Okay. Starting from simple to complex. And in the next video, we'll try to solve competitive programming kind of questions using list data structures. Okay, because mostly uh, companies written examination. Okay, so uh, ask questions related to list data structure. Okay, so what kind of questions are asked in previous placement examinations? Okay, how we can use a list data structure to solve such kind of questions, that we'll see in the next video. So thank you one and all. So if you like the video, so please like and share this video. And if you are new to the channel, please subscribe to the channel and also turn on the bell icon for more such updates. Thank you one and all.